dear students. So in this class, in this session, we are going to see linear programming and also probability. Yesterday, all the calculus chapters were over. I hope that all of you are able to understand all those chapters. Now we are going to go into the chapter of linear programming and also probability. Both of them are very simple chapters. So if you understand the logics better and if you understand which formula to apply when, then you will be able to answer all the questions. So now let us go into the session and let's have a great time together. Thank you. Hello guys, now in this session we are going to see both the chapters, that is LPP as well as probability. Calculus whole part was over yesterday with the conclusion of differential equations. Now we go to the last set of chapters, that is LPP and also probability. So in this chapter LPP is very simple chapter. First you need to draw the graph, and from the graph you need to find the solution. Before drawing the graph itself, you may know the solution, you may know the answer to that question, but most of the questions they will be giving you to construct graphically. So that is the purpose why we are drawing a graph. So now let us see the objective of an LPP, that is linear programming problem. So the objective of the LPP is to find the optimal value. Optimal value means in your question either they will be giving to maximize or minimize your given linear function with respect to some conditions. Those conditions are called constraints. So to find the optimal value, that is maximum or minimum of a linear function of several variables, we would have already studied what is linear equation. So some linear equation will be given subject to some constraints. So based on that constraints, you will have to find the solution for it. You have to find suitable values and then determine the solution in the graph, and then you will have to find which value is maximum and which value is minimum. So that is the objective of this problem. So to find the optimal value, maximum or minimum of a linear function of several variables called objective function subject to the conditions. As I told you, conditions are otherwise called constraints. So when you are drawing a graph, the common region determined by the constraints means conditions, including the non-negative constraints. So the common region determined by the constraints and also the given question. So that is called as feasible region. From that feasible region only you need to find the solution. So any point in the feasible region that gives the optimal point is called the optimal solution. So the most preferred method or the most ideal method of solving LPP problem is corner point method. So corner point method, that's what I would have given the explanation how the feasible solution is obtained, how the maximum or minimum value, how the optimal value is obtained from the feasible solution, all those things I would have given. So find the feasible region of LPP and determine its corner points, vertices, either by solving the two equations of the line intersecting. There will be two given equations in some of the cases, like x plus 3y less than or equal to 24 and 2x plus y less than or equal to 12. So you need to solve those two equations. That point or that value of x and y is nothing but the point of intersection. So, and also you will have to take the constraints value and then find the value by inspection. Inspection is otherwise called trial and error method. So by combining both of them, by using both trial and error and also the point of intersection, you need to draw the values given, and that graph, that particular region will be the feasible solution. Based on the feasible solution, you will need to substitute which is maximum point or the minimum point. So evaluate the objective function z is equal to ax plus by at each corner point. Let capital M and small m denote the largest and smallest values of these functions. So if the feasible region is bounded, so now we are going to discuss only about the bounded solution. Unbounded solution they won't be giving for your exam. For your exam point of view, only your bounded region is very important. So as of now we can skip this 3b. Just for your knowledge point of view I have written. So when the feasible region is bounded, M, that is you would have already found out which is the maximum value by substituting the x and y value that would have already found out on seeing the question. So M value is nothing but the maximum value and small m gives you the minimum value. So now in case it is unbounded, specifically the given region is unbounded. This is not important from the exam point of view. Just now I am explaining. M is maximum of Z. Capital M is maximum of Z if it is open half plane of Ax plus By is greater than M, has no point in common with feasible region. Suppose if many points lie outside the feasible region, in that case there is no maximum value. Similarly for the minimum condition also, small m is the minimum value, and if open half plane determined by Ax plus by By is less than M, has no point in common with the feasible region. So basically your points should lie inside the feasible region. So that is the main objective of this problem. Otherwise Z has no minimum value. So some of the examples I have given, examples 1, 2, 3, 5 from your textbook. All these questions are taken from your new edition textbook. So examples 1, 2, 3, 5 and in exercise 12.1 the first 3 sums. Mostly for your exam point of view, you will be asked only your bounded region. So no need to concentrate on unbounded region because as it is very time consuming. So I will explain LPP on a gist. So how to do the question. Suppose if we take one example. Let for example solve the following linear programming problems graphically. Z is equal to 4x plus y. You will have to maximize this function. Z is equal to 4x plus y. Subject to the constraints x plus y less than or equal to 50. 3x plus y less than or equal to 90, and x is greater than or equal to 0, y is greater than or equal to 0. So now for analyzing the points, that is the vertices, 0, x is greater than or equal to 0, y is greater than or equal to 0, they are given. So you can take 0, 0 as one value, and then second value, first you can solve this equation, and if you solve this equation by assuming it as equal, because they have given in the question x plus y less than or equal to 50 and 3x plus y less than or equal to 90. Suppose if you solve this equation by assuming it to be equal, then you will be getting the value 20, 30. Yeah, you will be getting the value 20, 30. X as 20 and y as 30. So you have now got two values. One is 0, 0 and another one is 20, 30. Two more values you can construct by taking x as 0 here. If you take x as 0, so this will be 0, 50. So 0, 50 can be one point, and another point you can take y as 0 now and put it in the second equation. If you take y as 0, then from the second equation you will be getting 30, 0. So there are 4 points. There are 4 points which can be plotted in a graph. One is 0, 0. Another one is 30, 0. Another one is 20, 30. Another one is 0, 50. Now if you plot these 4 values in a graph, then you can see that the feasible region is bounded. That is, all the points lie inside the region. So that is called as bounded region. If some points lie outside the region, then it is called unbounded. Most of the points lie outside the region, it is called unbounded. Here most of the points lie inside the region, so it is a given bounded curve. So here if you see, if you substitute all these values, that is 0, 0 in your question, which is z is equal to 4x plus y, and 30, 0 and 20, 30 and 0, 50 in your question, that is z is equal to 4x plus y. Suppose if you substitute 0, 0, you will be getting the value as 0, and if you substitute 30, 0, you will be getting the value 120, and if you substitute 20, 30, you will be getting the value 110, and if you substitute 0, 50, you will be getting the value 50. Here the maximum value is 120. So this is how you have to solve this question. Suppose if they ask you minimize the value, so the minimum value is 0. So 0, 0 is nothing but that is the solution for this. So this is how you will have to solve your given LPP problem. Now I have explained you everything along with an example solution, example problem. So this is how LPP problem should be solved. Next we go to the concept of probability. It is also a very simple chapter. So there are these many topics. First, conditional probability, independent events, Bayes theorem, random variables, probability distribution function, and also mean. These 3 topics Last three topics, random variables, probability distribution function, and mean, are very similar to each other. So by drawing the probability distribution function, you can find the mean easily. We can see how that happens actually. So first we go to the first concept, conditional probability. Conditional probability is, there are two cases of conditional probability. First one is, let E and F be the events. Suppose let E and F are the events, and I have defined P of E bar F. P of E bar F is nothing but probability of the event E happening when F has already occurred. When F has already happened. Please note that. Probability of E happening when F has already happened. So that means what? That is nothing but P of E bar F. So which is nothing but P of E intersection F divided by P of F. So this is a formula. And for P of F bar E, that means what? Probability of F happening when E has already happened. So this is the meaning. So you just have to understand the concepts. So if you understand the concepts, if you understand the definitions better, then the problem application to the problem becomes very easy. So probability of F bar E is nothing but P of E intersection F divided by P of E. Also you have some other results for conditional probability, that is P of A dash bar B. Now let us see the definition of P of A dash bar B. What is the meaning? It's the same, using the same logic as we did for P of E bar F. Now what will be the definition of P of A dash bar B? Probability of A dash happening when B has already happened. What is the meaning of probability of A dash happening? Probability of A dash happening means probability of A not to happen when B has already happened. So understand the difference. Probability of A not to happen when B has already happened. So this is how you will have to interpret the question. So that is nothing but 1 minus P of A bar B. And P of A bar B dash. What is the meaning for this? Probability of A happening when probability of uh, probability of A happening when probability of when B dash has already occurred. When B dash has already occurred means what? When B has already experienced a failure. So probability of A happening when B has already experienced a failure. So that is the meaning of P of A bar B dash. So please be very careful with the symbols. So P of A bar B dash means probability of A happening when B has not occurred. So that means probability of, the formula is P of A intersection B dash whole divided by P of B dash. So this is the formula. So for the symbols, you guys have to be really very careful. Okay, now I have given you, this is nothing but the addition theorem of probability, which we learned it in very lower classes. The same theorem I have used here. I have extended that for conditional probability as well. So suppose if A, B and F are all events under S such that P of F is not equal to 0, then P of A union B slash F, that is probability of A union B happening when F has already happened. That means that is equal to P of A bar F plus P of B bar F minus P of A intersection B slash F. Because it is nothing. Why? Because P of A union B, from the addition theorem of probability, P of A union B equal to P of A plus P of B minus P of A intersection B. That's why it is coming like this. So P of A union B slash F equal to P of A bar F plus P of B bar F minus P of A intersection B bar F. So now we are using the two formulas that we learned already under conditional probability. So P of E bar F equal to P of E intersection F by P of F, and P of F bar E is nothing but P of E intersection F by P of E. Suppose they may be giving you this value in your question, like P of E intersection F or P of F intersection E, and also P of F and P of E, the values will be given, and they will be asking you this to find P of E intersection F. That concept is called multiplication theorem of probability. Why? Because we are multiplying, we are cross multiplying here. P of E intersection F is nothing but P of F into P of E bar F, and similarly P of E intersection F can also be written as P of E into P of F bar E. If you are being given this conditional probability value and also a probability of any event, then you can find P of E intersection F, that is E or F. So this is how we will have to find out. Sorry, P of E and F, because OR means union. Okay, now let us go to the concept of independent events. I have written the definition first for independent events because you guys should be able to understand what is independent events. If E and F are events in sample space S, such that probability of occurrence of one of them is not affected by the other. I have given one example also. So out of 52 playing cards, assume E to be the event that the drawn card is a spade. So totally how many spades are there? Totally you have 13. And probability of F be the event that drawn card is an ace. So totally you have got 4 aces. Okay, now P of E, since they have given it as a spade, so it is 13 by 52. So which is 1 by 4. And P of F, since it is given as an ace, it should be 4 by 52. Okay, which is 1 by 13. Now please note that P of E intersection F, that means what? P of E intersection F, A spade can also be coming. So it can also be an ace and also a spade. So only one is there like that. So that is what P of E intersection F is 1 by 50. Based on these two conditions, you can tell that the given two events are independent. First of all, you will have to check for this condition. If P of E intersection F equal to P of E into P of F. P of E intersection F value is 1 by 52. P of E is 1 by 4. P of F is 1 by 13. So 1 by 4 into 1 by 13 equal to 1 by 52. That is equal to this. So if both of them are equal, LHS equal to RHS, then you can say for sure that E and F are independent. That is from the value wise you can tell. If not, you will have to find the conditional probability P of E bar F, which is nothing but P of E intersection F by P of F as per the formula. P 1 by 52 divided by 1 by 13. So 13 should go to the numerator and it will be 1 by 4, which is nothing but P of E value. So E has not affected the occurrence of E has not affected the probability of occurrence of it. That is what I have given in the beginning itself, the definition of independent event itself. So similarly, P of F bar E, P of A intersection F by P of E. So 1 by 52 by 1 by 4, which is 1 by 13, which is equal to P of F. So F, the event F has not affected the probability of occurrence of E. So both of them have happened without any connection to each other independently. So that is called independent events. If you are confused about these two data, the second data, you can use the first data. First data is very simple. If P of E intersection F, if it should be equal to P of E into P of F. If both the P of E and P of F, the product of both of them, if it is equal to P of E intersection F, then definitely you can tell that E and F are independent events. So that is very easier method. So I have given you again the same thing. So conditions, if A and B are independent, then also A and B dash are independent. So this is a very important condition. So P of A intersection B equal to P of A into P of B, and P of A union B equal to 1 minus P of A dash into P of B dash. So this is another property. Bayes theorem. I have given you this formula for Bayes theorem. Now we need to find, see an example for Bayes theorem to understand its concept better. So bag 1 contains 3 red, 4 black balls, and bag 2 contains 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. So let us take E1 as the probability drawn from bag 1 and E2 to be the probability drawn from bag 2 and A to be the red ball. So now what is probability of E1? Probability of E1 is red from bag 1. So which is 3 out of 7. Probability of E1. E1 is nothing but choosing bag 1. So there are only 2 bags. You got to choose only one. So P of E1, it is nothing but half, and P of E2 is also half. Equally likely outcomes. And P of A is, P of A bar E1. What is this meaning? Probability of A happening. That is, you have to choose a red ball from bag 1. Because probability of E1 has already happened. So P of A bar E1 is nothing but probability of choosing a red ball from bag E1. So from bag E1, the probability of choosing a red is 3 out of 7. So you will have to learn the symbols carefully. P of A bar E1 is nothing but 3 by 7. And P of A bar E2 similarly is probability of choosing a red ball from bag 2, because E2 you have already chosen. So now probability of choosing a red ball from the second pack. So which is nothing but 5 out of 11. So now what we need to find? Probability that it is, you need to find that it is red and also it is chosen from back 2. That is, you need to find probability of E2 bar A. E2 bar A. Why? Probability, what is E2? It is chosen from back 2 and also already they have given you the condition that it is red. So it is chosen from back 2. So probability of E2 bar A. So now it is just nothing but you need to apply these values, P of E2 into P of A bar E2 by P of E1 into P of A bar E1 plus P of E2. This is the denominator is nothing but sample space. The numerator is nothing but the total selection. Favorable events by sample space. Same as that. So P of E2 into P of A bar E2. Now you know all the values. You know all the values. Now you need to apply it here and then find out. You will be getting your final answer as 35 by 68. Now probability distribution. So I have given you an example for probability distribution. Find the distribution of number of doublets. Doublets means it should be identical on both the days. If 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, like that. So totally there are 6 doublets, which is, possible. 6 doublets, which is possible, which is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So in 3 throws of a pair of dice and hence find the mean. Suppose X, now we need to find the probability of a doublet first. Probability of doublet, as I told you, it is 1 out of 6. Because totally if 3 pairs of dice are thrown, if 3 throws are being done, so it is nothing but 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So it is nothing but 6 out of 36. 6 out of 36 is nothing but 1 out of 6. So if 3 pairs of dice or 3 throws of dice are done, then it is 1 by 6 into 1 by 6 into 1 by 6. Like that it will come. So now P of X is equal to 0. Now we have found out that the probability of doublet is 6 out of 36, which is 1 by 6. Now probability of not a doublet. So 0 doublets, that means 1 minus 1 by 6, complementary events, it is 5 by 6. So for 3 throws of dice, so it is 5 by 6 into 5 by 6 into 5 by 6, which will give you the answer 125 divided by 216. So now P of X is equal to 1. X is equal to 1 means 1 to be a doublet and 2 to be a non-doublet. So 1 to be a doublet, it is 1 by 6. 2 to be a non-doublet, it is 5 by 6 into 5 by 6. This is for 1 throw of a dice. Now you are asked to do 3 throws of a dice. So like that you will have to repeat it 3 times. 5 by 6 into 5 by 6 into 1 by 6 plus 5 by 6 into 5 by 6 into 1 by 6. Like that. Similarly, X is equal to 2. X is equal to 2 means 2 doublets and 1 non-doublet. So 2 doublets is 1 by 6 into 1 by 6 and 1 non-doublet is 5 by 6. So you will have, this is for a single throw of dice. For 3 throw of dice you will have to repeat it 3 times. And probability of X is equal to 3. Everything is a doublet. If everything is a doublet, it is nothing but 1 by 6 into 1 by 6 into 1 by 6. So this will be the value. After this you need to substitute it here. X is equal to 0, 1, 2, 3, and then you need to write all the values, pounded out values here. And then if they are asking you to find mean, you need to do this into this, this into this, plus this into this, plus this into this, and so on till the total number of values. So this is how you need to find the mean. So I have given you the questions. See, all these questions are from the new edition textbook. In the new edition textbook, the concept of random variables and mean are not there, but it is there in your exam syllabus. So what I suggest you is, you just refer all the example sums under probability distribution with mean in your old edition textbook. and if you do that, it will be very helpful for you. So with this, linear programming and probability concept is over. I am sure that all of you would have been able to understand this concept much better. We will deal with more videos in the future. Thank you.